Okay, now we can start our today's session. In today's session, we are supposed to study about the op-amp configuration. So here, firstly, we will see about the closed loop op-amp configuration. If you see, we can use op-amp as integrator, we can use op-amp as inverting amplifier, we can use op-amp as adder, subtractor, we can use op-amp as non-inverting amplifier because we have seen if we are supposed to use the op-amp at that time, if we are supposed to give positive input. At that time, we can give positive input at the pin number 3. And if we are supposed to give negative input, we can give at the pin number 2, which is the inverting terminal. So, which we will give us the inverting output. So, here we are supposed to study now about the op-amp configuration. So, we can use op-amp configuration in different devices, like we can use op-amp as inverting amplifier, we can use other subtractor, we can use op-amp as non-inverting amplifier, integrator, voltage follower, differentiator, instrumentation amplifier. We will see one by one. So here, firstly we will see about the inverting amplifier. As the name given, if we are giving the input at the inverting terminal of operational amplifier, at that time it will give us the output that will be inverted. It means what? If we are giving here sinusoidal wave at the input, at the output we will get the cosine wave. It means what? If we are giving the input at that time, we will get the output that will be the 180-degree out of phase with respect to the input signal, because this inverting amplifier will give us the output that will be inverted with respect to the input signal. So we can say about the inverting amplifier, like in inverting amplifier, the signal which is to be amplified, we can apply that signal at the inverting terminal of operational amplifier. Then we will get the amplified output. Yeah, it will be the amplified, but it will be the 180-degree out of phase, or we can say that will be inverted with respect to the input. So here, firstly we will see the diagram. You can see here. If we are having the op-amp, what we can say, it will symbolically look like this. This is the differential amplifier. But symbolically, if you see, op-amp will look here. Op-amp will look like this. It means what? We can give here positive supply. We can give positive supply here. We can give negative supply here at the pin number 4. If we are supposed to give negative input, we can give to the negative terminal. If we are supposed to give positive, we can give to the positive terminal. And output we will get at the here. We are taking symbolical structure of the op-amp like this. So here we are supposed to study about the inverting. So here, if we are taking the IC 741, we are saying this is the inverting output, this is the positive. At that time, we are supposed to give input. Where we will give? We will connect that input to the inverting terminal. Because here we will need the output that will be the inverted with respect to the input. So we will get the output from this side. So we can say VO. Here we can use resistance to sorry. Here we can use the resistance because by using the op-amp we are supposed to increase, we are supposed to amplify the input signal. So here when we are connecting the output to the input, we can give through this resistance, we can call this as the RF resistance, the feedback resistance. Or we can say, we can give the name like the R2. So here, when we will give the input, that will be the sinusoidal. We will get the output that will also having the wave like the sine, but it will be the cosine. It will be the 180-degree phase shift with respect to this, but it will be the amplified. If you see, as compared to this, we will get here the amplified output. So here, this is the circuit diagram for the inverting amplifier. This is the input waveform. This is the output waveform for the inverting amplifier. So here we are saying as shown in the figure input signal we can connect to the inverting terminal via resistor R and we can give output to the inverting terminal by using the feedback resistors RF or we can say R2. We are connecting that resistor in between the inverting terminal of op amp and the output. So here we will get the inverting amplifier. Here we are connecting output to the input. Which input? To the inverting terminal. How? By using the feedback resistor. So here we are aware about the voltage gain. Voltage gain is nothing but output voltage with respect to the differential voltage. It is nothing but the input voltage. Who have joined? Sneha, you are supposed to join on the time. Okay. So here, what we are saying, Sneha, now we are studying about the inverting amplifier. Inverting means what? If we are giving the input to the op amp at that time, it will give us 180-degree phase shift with that the input. That output will be amplified, but there will be the 180-degree phase difference between output and the input. At that time we are saying that amplifier as the inverting. So here we are supposed to give input that we will connect with the inverting terminal, so we will get the inverted output. So here we can see we are aware about the voltage gain. We can write voltage gain is equal to the ratio of output voltage with respect to the input voltage. If we are using the differential amplifier, we are saying if there is a difference between inverting and non-inverting terminal, we can take that differential input voltage equal to V1 minus V2. So now what we are saying here, we are saying V1 equal to 0 because what we have done here, we have connected non-inverting. Ni is nothing but non-inverting, non-inverting, or we can say the positive. The positive terminal we are connecting with the ground. So according to the virtual ground concept, what we are saying, if inverting or the non-inverting, if one is having the 0, at that time other terminal will also have the 0 voltage. We have seen this concept in the virtual ground concept. If the non-inverting terminal is connected to the ground, it means what? If positive is connected to the ground, then due to the virtual short exists between two terminals, inverting and non-inverting, due to which the inverting terminal also will be at the virtual ground, or we can say it will also have the 0 volt voltage. So here, as we have seen here, we are connecting V1 directly to the ground. So we can say V2 will also have the 0 volt voltage according to the virtual ground concept. So here we are saying infinite resistance will be get at the input. So we can say the current IP2 going into negative terminal, that will be 0 because we are aware about the Ohm's law and we have seen current is inversely proportional to the resistance V equal to IR. So R equal to V by I. You can write. So you can say current is inversely proportional to the resistance. So here, if the value of input resistance is infinite, the value of current will be very low, or we can say it will be 0. So here we will get the value of current flowing through R1 and Rf is same, that will be equal to R because we are taking the voltage at that time. Some current we are saying it will go to the inverting and some will go to this resistance. But what we are saying, but we are saying the value of IB2 is 0 because here we are having the infinite resistance. So we can take that current directly will flow through this, that RF resistance. So we can take here, hence current through the R1 and RF will be the same, that will be equal to I. So input voltage according to Ohm's law, I into R1. Output voltage, I into RF. But here if you see here, it is incoming at this node, it is outgoing at this node. It is outgoing at this node. So we can take that voltage VO equal to minus I into RF. Or we can say it is connected to the inverting terminal. So we can take minus I into RF. So here, now we are having the output voltage that will be in terms of input voltage and the gain. That will be AV into Vin. But we are having the equation for V in, we are having the equation for VO, you can write here. So you will get voltage gain equal to minus RF upon R1. If you solve this, I will get cancelled. You will get AV equal to minus RF and R1, it is in multiplication with AV. So it will go to the left side in the denominator. Minus RF upon RF. So R1. So now you can see negative sign indicates that you will get inverting output at the output of inverting amplifier, or we can say there is a 180-degree phase difference between the input and the output voltages. So here, now we are supposed to study about the non-inverting. What we can say about the non-inverting? If you compare non-inverting with inverting, here you can see will give the input that will be to the non-inverting terminal, and output signal will be amplified, but it will not have phase difference with respect to the inverting, because here we are connecting input to the non-inverting terminal. Firstly, we will see the diagram. Here, what is the difference? If you see, we are taking the same. We are taking here these two resistors. But here, instead of V2, negative terminal, we are connecting input voltage to the V1, which is positive. रिमेनिंग सर्किट द सेम, बट यहाँ का जो इनपुट वोल्टेज है वो यहाँ से निकाल के पॉजिटिव टर्मिनल को कनेक्ट किया है. सो यहाँ पे क्या होगा, इनपुट और आउटपुट दैट विल हैव 0 डिग्री फेज. There will be no phase difference between the input and the output. So here we can see about the non-inverting amplifier. So here, what we are saying about the non-inverting amplifier, here we are supposed to connect input signal that to the positive, or we can say the non-inverting terminal of the non-inverting amplifier. Here we are connecting the feedback resistors that will be in between output and the inverting terminal. And here we will get the output that will be in phase with the input signal. For ideal op-amp, we are saying Ri equal to infinite. Therefore, current entering into both the input terminal of op-amp will be 0, because we are saying ideally we will have infinite input resistance. So we can say current which will enter into the both input terminal, to inverting terminal and to the non-inverting terminal. We can take that current equal to 0. So here we will have the value of voltage that will be across R1. If we are supposed to find the voltage across R1, how we can find? We can find according to the voltage divider rule, because if you see R2 is connected in parallel with the R1. So according to the voltage divider rule, you will suppose to find the voltage that will be across R1. So you will get R1 upon R1 plus Rf into total voltage. We can take total voltage that will be the output voltage, VO. But according to the virtual short concept, if you see in the inverting, we have used virtual ground concept. If we are saying there, inverting, we are connecting to the ground, we can take non-inverting voltage, input voltage equal to 0. But here, what we are doing here, we are saying here, we are having ideally infinite input resistance, due to which the current flowing through both inverting and the non-inverting input terminal is 0. And if we are finding the voltage that will be the across R1 according to the voltage divider, we will get That equation R1 upon R1 plus Rf into VO. That is nothing but the output. But we are aware about the virtual short. According to the virtual short, what we are saying? We are saying the input voltage equal to V1 equal to V2. Both are shorted, so both input are having the same voltage. So here we are having the equation for the V2, so we can take that equation for the Vin. So you can write Vin equal to the same equation R1 upon R1 plus Rf into VO. So we can now find the equation for the gain. Gain equal to VO upon Vin. VO as it is Vin ka equation you can write in the form of VO. VO will get cancelled and you will get AV equal to R1 upon Rf plus R1, or you can rewrite that equation. How? You can write, you will get the equation VO upon Vin. तो तुम्हारा इक्वेशन क्या हो जाएगा? VO get cancel and 1 upon R1 upon Rf plus R1. So you can write that equation as Rf plus R1 will get in the numerator, because it is 1 divided by R1 upon Rf plus R1. So it will go in the numerator and R1 will get in the denominator. So you can write that equation as R1 plus Rf upon R1. Or if you are solving this, you are dividing both by R1. You will get AV voltage gain equal to 1. R1 upon R1 you will get 1 plus Rf upon R1. So here for the inverting amplifier you will get the equation minus Rf upon Rf. So you can say here output will be 180-degree phase shift with respect to the input, because we are having the equation that will be the negative minus Rf upon R1. But here you will get the equation 1 plus Rf upon R1. It means what? Here we will get the output that will be amplified, but that will be in phase with respect to the input. So here we can say the positive sign indicates that input and output are in phase with each other. And if you see, closed gain is increases with unity. Because if you see in the negative also, we will get the same equation, Rf by R1. But that will be negative. But here, as compared to the Rf R1, you are having the gain that will be greater than unity. That will be Rf plus R1 plus 1. So we can say that will always be greater than 1. This is the circuit diagram for op-amp. Which op-amp? The non-inverting. Here we are giving input to the non-inverting terminal. And here these are the waveform for the input voltage and the output voltage for the non-inverting amplifier. So here in today's syllabus we have seen about the inverting and the non-inverting amplifier. In inverting amplifier we are saying we are supposed to give input to the inverting terminal. So we will get the output that will be 180-degree phase shift with respect to the input signal. So here if we are giving the input to the inverting terminal, we can give the output that will be as a feedback to the input to the inverting terminal by using the feedback resistor R2, or we can say that resistor as a RF. This is the input voltage which we are giving at the V2 terminal of the inverting amplifier at the negative terminal. So we will get the output that will be inverted with respect to the VE. So here we can say the amplified output signal will be 180-degree phase shift with respect to the input signal. And if you see here we are connecting P in, that will be to the inverting terminal. We can connect by using internal resistance. We can say the R. It means what? If we are supposed to connect input voltage to the inverting terminal, we can connect via resistance R1, and we can connect output to the input by using the feedback resistor RF. So here we are connecting non-inverting terminal directly to the ground. So here according to the virtual ground concept, if we are connecting non-inverting terminal to the ground, we can say virtual ground concept will tells that inverting terminal will be also at the ground potential. So we can take V1 equal to V2 equal to 0 volt. But we are aware about the output voltage that will be in terms of input voltage and the voltage gain. So we can write VO equal to AV into VD. VD is nothing but it is the differential voltage. It is the difference between two input voltages, non-inverting and the inverting. But according to virtual ground, we are saying we will get V1 equal to V2 equal to 0 volt. So if we are saying we are having the internal infinite input resistance, we can say the current flowing through the inverting terminal will be 0. So we can take the current that will be flowing through the R1 resistor. That will be the same current flowing through the R1. So we can take direct V in equal to I into R1 and VO equal to minus I into R1, because we are saying here we are having the value of IB to 0. So why? Because we are taking here infinite input resistance between these two resistors, V1 and V2. So here we can take that current will directly flow through this. But here if you see, we are connecting that R2 to the negative. So we can take that as RF minus RF into I. And you can take input current that will be equal to V in into R1. It means what? You can take V in equal to I into R1, or you can take I equal to V in by R1. So here we are saying current flowing through R1 and RF are same. So you can take V in equal to I into R1 and VO equal to minus I into RF. We are taking negative here because this is connecting to the inverting terminal. So here now we are having the equation for the output voltage that will be in terms of gain and the input voltage. So here now we can write the equations for V in and VO here in this equation, the output voltage. So your equation will become minus I RF equal to AV into I R1. If we are solving this, I will get cancelled. You will get AV equal to minus RF upon R1. So here we can say that amplifier as an inverting amplifier, because we will get the output that will be 180-degree phase shift with respect to the input voltage. Now we are supposed to study about the non-inverting amplifier. So here in non-inverting amplifier, we will give the input that will be to the non-inverting terminal. So here we will get the feedback resistor that will be connected in the same, which we are connecting in the inverting amplifier between output and the inverting input terminal. But here we are saying we are giving input voltage to the positive terminal, non-inverting terminal. So there will be the phase 0 degree in between output and input. So we can say input and output voltages are in phase with each other. And ideally, we are saying we are having the infinite resistance between V1 and V2. So therefore, current entering in both will become 0. So we can take I1 equal to I2 equal to 0 ampere. So here we can use the voltage divider rule to derive the value of voltage across the R1 according to the voltage divider. You will get R1 upon Rf plus R1 into VO, output voltage. But according to virtual short, we are saying if one is voltage is connected to other, these are virtually short. So we can take V in equal to V1 equal to V2. So you can take that V2 equation for V in. Again, what we are having? We are having the voltage gain equation. Now we are having the V in terms of V. Why we are solving like this? Because we are supposed to find the value of voltage gain for inverting and the non-inverting. तो वोल्टेज गेन का इक्वेशन क्या होता है? आउटपुट वोल्टेज अपॉन इनपुट वोल्टेज. सो हम दोनों जब इन्वर्टिंग और नॉन इन्वर्टिंग के लिए सॉल्व कर रहे हैं तो हम आउटपुट वोल्टेज का जो इक्वेशन है we will take as it is, and input voltage का equation we can write in the form of output voltage according to the their virtual ground and here virtual short concept. तो हमें यहाँ पे V in का इक्वेशन VO के फॉर्म में मिल गया है. So now you can write the V in equation in the form of VO, and VO will repeat as it is. So VO will get cancelled, and you will get the equation that will be in the form of resistance. So you will get AV equal to 1 upon R1 upon RF plus R1. If you solve, you will get R1 plus RF upon R1. Or you can write voltage gain equal to, for the non-inverting amplifier, equal to 1 plus RF by R1. So here we will get the positive sign. So we can see here input and output are in phase with each other, and closed loop gain will always greater than unity, because if you see the equation for the voltage gain for the inverting, you will get the same equation RF by R1, but this is negative because here we will get the 180-degree pitch. But here in the non-inverting, you will get 1 plus RF by R1. So you can say that voltage gain will be greater than unity. Remaining syllabus we will see in the next session. Now I am taking your attendance. If anyone is facing any issue, you can ask. You all are supposed to do practice. You all are supposed to again view these PPTs, and you can go through the video lectures which I am sharing on the classroom, Google Classroom. Okay, thank you. You guys can leave now. We will conclude our session.